Hi there, senior high school students! Welcome back! This video is about general mathematics for senior high school grade 11. Before we start, do not forget your pen and paper to write your solutions later on, and remember, you can always pause and play this video whenever necessary. So, are you ready? Let's start! As a continuation to our lesson, we are now going to discuss about operations on functions. In your previous lesson, you learned to determine functions and evaluate a function at a certain value. Now here, we are going to learn the four operations: addition, subtraction, multiplication, and division of functions. So we have here our first operation, which is addition. And it is denoted by f plus g of x is equal to f of x plus g of x. Now let's try to add functions. Given f of x is equal to x plus 5 and g of x is equal to 2x minus 1, let us find f plus g of x. First, let's apply the definition of addition of functions. So we have f plus g of x is equal to f of x plus g of x. Next, replace f of x and g of x by the given values. So our f of x is x plus 5 plus our g of x is 2x minus 1. Next, let us combine like terms. So x plus 2x is 3x. Positive 5 plus negative 1 is positive 4. Therefore, our final answer is 3x plus 4. Now how about when we have a certain value of x? Like this. So as you can see, the value of x here is 3. And by applying the definition of addition of functions, we will have f of 3 plus g of 3. Now using the same functions, we have x plus 5 plus 2x minus 1. Next is replace f of 3 and g of 3 by the given values. So our given value is 3. Meaning to say, we have to substitute 3 to all the x's of the functions. Now, let's perform the operations. So we have 3 plus 5 is equal to 8 plus 2 times 3 is 6 minus 1 is 5. Lastly, we have to add. So 8 plus 5 is 13. Okay. So now that we are done with addition, let us now move on to subtraction. Yes, we can subtract functions too. And it is denoted by f minus g of x is equal to f of x minus g of x. Now let's try this operation. So given the same functions, let us find f minus g of x. So first step, let us apply the definition of subtraction of functions. So we have f of x minus g of x. Next step, replace f of x and g of x. So what is our f of x? That is x plus 5 minus, what is our g of x? 2x minus 1. Next step, let's distribute the negative sign. So x plus 5, negative times 2x is negative 2x. And negative times negative 1 is positive 1. And lastly, let us combine like terms. So x minus 2x is negative x, and positive 5 plus 1 is positive 6. Therefore, our final answer is negative x plus 6. Now, how about when we have a certain value of x? So, using the same functions, let us have f minus g of 2. Now, our first step, apply the definition of subtraction of functions. So, we have f minus g of 2 is equal to f of 2 minus g of 2. Again, this just means that we are going to substitute 2 to all the x's of the given functions. So, we have to replace f of 2 and g of 2 by the given value. So, what is our x again? 2. So, 2 plus 5 minus 2 times 2 minus 1. Now, let's perform operations. So 2 plus 5 is 7 minus. So what's inside the parenthesis? 2 times 2, 4 minus 1. Now let's subtract 7 minus 3. And the answer is 4. So f minus g of 2 is equal to 4. Now let us have multiplication, and it is denoted by f times g of x is equal to f of x times g of x. Now, using the same given, let us now multiply the functions. So we have f times g of x, and by applying the definition of multiplication functions, we will have f of x times g of x. So our next step is replace f of x and g of x. So what is our f of x? We have x plus 5 times. What is our g of x? 2x minus 1. Now, let us multiply these binomials using FOIL method. So x times 2x is 2x squared. X times negative 1 is negative x. Positive 5 times 2x is positive 10x. And positive 5 times negative 1 is negative 5. And to simplify, we have to add negative x and positive 10x. Therefore, we will have 2x squared plus 9x minus 5. Now, how about division of functions? Yes, we can divide functions too. And it is denoted by f divided by g of x is equal to f of x divided by g of x. Now, let's have an example. Given f of x is equal to x cubed minus 27 and h of x is equal to 4x minus 1, find f divided by h of x. So first step, let us apply the definition of division of functions. So we will have f of x divided by h of x. And for the next step, replace f of x and g of x. What is our f of x? X cubed minus 27 divided by, what is our h of x? 4x minus 1. Now, since there are no common factors in the numerator and the denominator, this is already the simplest form. Therefore, f divided by h of x is equal to x cubed minus 27 over 4x minus 1. So now that we are done with the 4 basic operations of functions, it's time for a level up. Let us now have... In composition of functions, we will have a lot of substitutions. You learned in your previous lesson that to evaluate a function, you will just substitute a certain number in all of the variables in the given function. Similarly, if a function is substituted to all variables in another function, you're performing a composition of functions to create another function. And some call this as function of functions. Now look at this function. This can be read as f composed of g of x is equal to f of g of x. So we have g of x here as the domain of f of x. So notice how the letters stay in the same order in each expression for the composition. The letters f of g of x tell you to start with the function g. And remember to always start with the function in the innermost parenthesis. If you become confused as to where to start when you see the notation, start by rewriting the notation to be f of g of x. Then you can see that you need to start with the innermost parenthesis, which in this case will be the function g. How about this function? G composed of f of x is equal to g of f of x. What will be our domain? It should be f of x. Now let us have an example. Given f of x is equal to x squared plus 5x plus 6 and h of x is equal to x plus 2, find f composed of h of x. First, let's apply the definition of function composition. We have f composed of h of x is equal to f of h of x. So the idea here is we have to substitute a function to another function. Now let's substitute. What is h of x from the given? That is x plus 2. So we replace h of x by x plus 2. Now pay attention to this. We are now going to use the function f of x. Since f of x is equal to x squared plus 5x plus 6, we will replace all of its x's by x plus 2. So now we have x plus 2 quantity squared plus 5 times x plus 2 quantity plus 6. Next, perform the operations. So x plus 2 squared is x squared plus 4x plus 4. Positive 5 times x is positive 5x. Positive 5 times positive 2 is positive 10 plus 6. Now let's combine like terms and simplify. So that will be x squared plus 9x plus 20. Now how about we try to see this in an illustration? Now look at this illustration. It shows that composition of function is putting a function inside another function. Using the same example, as you can see, we have the function f composed of h of x, where h of x, which is x plus 2, is being put into another function f of x, which is x squared plus 5x plus 6. That is why we have substituted x plus 2 in all of the x's of x squared plus 5x plus 6. And with that, we came up with the answer x squared plus 9x plus 20. Let's try to assign value to x. Using the same given functions, let us find f composed of h of 4. meaning to say, we are going to substitute 4 to all the x's of the functions. So first step, let's apply the definition of function composition. We have f composed of h of x is equal to f of h of x. Now, let's use the function we've had earlier since we have the same given functions. So we have x squared plus 9x plus 20. Next is, let's replace all x's by 4. So f of h of 4 is 4 squared plus 9 times 4 plus 20. Now 4 squared is 16. 9 times 4 is 36. So 16 plus 36 plus 20 is 72. Now it's your turn. I have prepared a 16-item assessment for you to try on. You may pause this video to copy the given, or you may take a screenshot. So here's another one. Allow me to read the direction. Given the functions g of x is equal to x squared minus 4 and h of x is equal to x plus 2, express the following as the sum, difference, product, or quotient of the functions. Meaning to say, we are going to identify what operation has been used for each item number in order to get those results. And to do that, you have to express each of them as sum, difference, product, or quotient. And for the last one, given the following, evaluate these functions. Again, you may answer these in your available time. I know you can do this. See you on our next lessons.